Okay, I'm going to do question 2, but I'm just going to go back to question 1 and look at it an easier way. And that was way back here with this one. In actual fact, it was easier to prove that if it was parallel, so if this one's 64, that one would be 64. And if that's 64 and that's 62, that has to be 54. And if this is isosceles, this can't be 54 or 62, because if that's 54 and that's 62, it's that same triangle, that would have to be 64, okay? And so this here, and this here are not isosceles triangle. This would have to be an isosceles triangle for these two to actually be the same angle, for these two to be parallel. Okay, so it's actually easier to prove that for these two to be parallel, these are the angles it would have to be. And because these have got 3 different angles, it's not isosceles. So sometimes it's easier to disprove than to prove, if you like. Never mind, I'll carry on. Okay, so question 2, when we get to it. Push stop, couldn't I? A child's practice goalpost has 1 pole and 2 supports, as shown on the left. So there's your pole and there's your 2 supports. The 2 supports are 90 centimetres long each. Okay. The pole is always perpendicular to the ground, so the pole's at 90 degrees. The diagram on the right shows the view from the side. OT is the 90 centimetres and OP is 70 centimetres. Find the length here. Okay, so we've got a right angle triangle, we've got 3 sides, we've got Pythagoras. But because this is the longest side, we go the 90 squared minus 70 squared, put it in brackets, take the square root, and we'll get the x. Because we know A, B, C with Pythagoras, we know A squared plus B squared equals C squared, and so we can rearrange to get to the fact that if we're trying to find A, we go C squared minus B squared would be A squared, so to find A we take the square root. Calculate the size of angle PTO. So PTO is this one here. So we have got an angle. We know that that's opposite, and we know that's the hypotenuse. So we're looking at the O and the H, and we can put our triangles, our SO, CA, TOA, and we're looking for one with the O and the H, no A. We don't need to find A. We've calculated that already. We might as well work with what we've got. We don't need it, we don't have it. So you could have used A, but it's better to use ones that you're given rather than ones that you've calculated. It's just safer. So our opposite, we're looking at SO. Okay, so sine theta equals 70 over 90. Sine theta equals 70 over 90, opposite over hypotenuse. Now, our theta is actually x, isn't it? So x is going to go undo sine, inverse sine, 70 over 90. Now, before you do anything there, you need to make sure that your calculator's on the right thing. I'll just show you that. Okay, so you need to go sine of 30, and it should equal 0.5. So I need to go shift set up, and I need to pop it into degrees, otherwise it's not going to work. Okay, and now it equals 0.5, so now I'm all good. So I go shift inverse sine bracket, the opposite divided by hypotenuse, close the bracket and execute, and I get 51. I'll call it 51.1. So x equals 51.1 degrees. Okay, so we'll just double check that. Where are we? Yep, 51.1. Finding it correctly, and I didn't bother working that one out. That's enough for today. If you like these, tell me so I'll make more. I'm not sure they're any good.